Okay, so next up in our week of transformations is reflections. So reflection is a flip over a line. We call that line just the line of reflection. Each point and its image are the same distance from the line of reflection. A reflection is also an example of a rigid transformation. Rigid transformation, remember, does not change the size or the shape. So if you look at the example here, they're both still triangles and they are both still the same size. It's just taken it and flipped it over. So some common lines of reflection are going to be the x-axis or the y-axis. We have vertical or horizontal lines in the form of x equals a number is going to be our vertical line, or y equals a number is our horizontal line. And then diagonal lines, for example, we're going to look at y equals x or y equals negative x. All right, let's go ahead and do an example. I'm going to do one each of a reflection over the x-axis and then a reflection over the y-axis. So first up, we have triangle ABC. We're going to go ahead and graph that. So -4, 2 is going to be A. 4, 7 is B. And 5, 1 is C. You want to be careful to connect these like as straight of a line as you can. Okay. We are reflecting over the x-axis, which is our horizontal one, and I'm just going to draw it in a little bit darker so that you can see it clearly. Now, we set up above each point, so these points, and their image are going to be the same distance from the line of reflection. So if A is here, it is 1, 2 boxes away from the line of reflection, so A prime should be just 2 boxes further away, right there. And then C is 1 box away, so then it should be 1 box down, and that becomes C prime. And then B, we're just going to count. So you're always counting straight up or straight down. 1, 2, 3, 4, 5, 6, 7. So then 1, 2, 3, 4, 5, 6, 7. And B prime ends up here. And that's my reflection. A started at -4, 2. It is now at -4, -2. B was at 4, 7. Now it's at 4, -7. And then C was at 5, 1. So C prime is at 5, -1. So you can see that when we reflected over the x-axis, the y values changed, but the x values stayed the same. Okay, let's look at a reflection over the y-axis. So we are going to first graph rectangle PQRS. So P is here, right then here. Q is at 2, 5. R is at 8, 3. And then S is at 7, 0. So there we go, and then I'm going to go back and take my other pen and just mark the y-axis this time. You don't have to do this every single time. I'm doing it for the sake of the video so that it's easier for you to see. Okay, so this time we're going to count left and right. So since P is 1 box away from the line, P prime is on the other side 1 box away. Q is 2, so then we count 2 over again. R goes from this edge all the way over to this edge. And then S went from 7, 0 to here. So now this time, P was at 1, 2, and P prime is now at negative 1, 2. Q was at 2, 5, now Q prime is at negative 2, 5. R prime will be at negative 8, 3, and S prime will be at negative 7, 0. So you can see when we flip over the y-axis, the x value is changing, but the y value is staying the same. So you can take this opportunity to go ahead and try 3 and 4. If you haven't done so already, you can just pause the video. I'm going to give you the coordinates of these in just a minute. So for this problem, when you have a point that is actually on the y-axis and you're reflecting, there's nowhere for it to go. It doesn't flip if it's on the line of reflection, so that just stays the same. Otherwise, all of the other x values changed. Now for the next one, we're flipping over the x-axis. So that's negative 2, 4. There we go. Okay, let's go ahead and move on. I want to show you other vertical and horizontal lines. So I'm going to do one of each. So here we're going to start by graphing triangle JKL. So J, K, and then L. Now I'm going to graph my line of reflection. So x equals 4 is going to be a vertical line that goes through 4. So that's this line right here. So this time, if your line of reflection is a vertical or horizontal line that's not one of the axes, I do want you to draw this line out. You can do it as a dashed line, you can do it in a highlighter or a colored pen, whatever works best for you, but this time I do want you to draw that line in. And then, now that we have our vertical line, we're just going to count just like we did. So since L was 1 away, then L prime is 1 away again. J was 3, so now it's J prime is 3, and then K was 2. And so that is our new point. This time, our values are going to change a little bit. So J was at 1, negative 1. J prime is now going to be at 7, negative 1. K was at 2, 3. K prime is now going to be at 6, 3. And then L was at 3, negative 2. So L prime is going to be at 5, negative 2. So it's a little bit easier to figure out the rule for that because our line is not the y-axis or the x-axis, so it's a little bit trickier. Let's look at a horizontal line. Moving on to number 7. So same as last time, I'm going to go ahead and graph my parallelogram. Okay, so there's C, D, E, F, And now my horizontal line is y equals 2. So it's going to be horizontal at positive 2. So that's right here. And now, just like I did before, I'm going to count. So I like to start with the points that are closest to the line, but you certainly don't have to do that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Two, 4, 6, 2, 4, 6. Oh, that was all the way at the top. So here we are. Ooh. And now I'm going to count. So C was at -4, -4. C prime is going to be at -4, +8. D was at -2, 0, and now D prime is at -2, 4. E was at 6, 1, and now E prime is at 6, 3. And then F was at 4, -3, and F prime is now at 4, 7. There you go. Okay, last example, I'm going to do one of these. So we're going to do the line y equals x. I'm actually going to go ahead and just graph that in for you really quick so that you can see it. So y equals x has a y-intercept of 0 and has a slope of 1. So it's a perfectly diagonal line that goes from the bottom left corner to the top right corner, like exactly diagonal, cuts the coordinate plane in half. So when I graph my shape now, my triangle, I'm still going to count, but I'm going to be counting diagonally. So let me show you what that looks like. -5, -2. Okay, let's start with Z. Z is one diagonal away from the origin or the line, so it's going to be another diagonal down, and it ends up there. We are always counting the diagonal boxes, so Y is going to be 1, 2, 3 and a half. So 3 and a half diagonal boxes. So then I've got the half here, and then 1, 2, 3 to get to Y prime. And then X is going to be 1 diagonal and a half. So then half and another 1. So when you are counting these, you are going to end up sometimes with counting these little half boxes. So that half box is going to count as the same half on the other side. So X prime is going to end up at -2, -5. Y prime is going to end up at 4, -3. And then Z prime is going to end up at 1, -1. So you can actually see that these vertices up here, all of these coordinates just flipped over. Right, X was -5, -2, and that became -2, -5. Now, if you are ever going to reflect over Y equals -X, that line is going to be this way, and then they are going to flip and become opposite. I don't think that you're going to see too much of that, but they will, if it comes up, I will definitely show it to you.